Hello, everyone. My name is Noah Housley. I am in Chem 105, and I'm just doing this to help me study, but it could also benefit you guys to, look over videos before tests, or if you don't understand something, hopefully, maybe in helping to understand things myself, that I use examples or explanations that help you understand. So, let us get down right to it. We're going to start over here in the corner. First, just like we go over in every school we've been in, elementary, middle school, we go over to the scientific method. Scientific method, first you start with observe. You observe a phenomenon, and then from that you can see if you can test a hypothesis. For example, let's use girls. I observe girls, or I might use my wife instead. My wife really likes it when I do the dishes. I observe that when I do the dishes, she kisses me. Maybe I could get an hypothesis of when I do the dishes, my wife will kiss me. That is an hypothesis. I test it. I do the dishes, and then I analyze to see what happens. See if did my wife kiss me or not. If she did or not, I can then make a theory and establish it. And then I repeat the process, and which means I just need to do the dishes a lot, which my wife will love. But if I do it enough, I can come up with a scientific law that my wife will kiss me when I do the dishes, and will happen every time. An example of a law, scientific law, is the law of constant composition, which is saying that in a sample of a compound, the chemical makeup, the atoms in those chemical makeups will always be the same. So, for example, if you had a gallon of H2O versus a milliliter of H2O, you will always have two oxygens and hydrogens in any of those samples. So that is the law of constant composition. The compound is always the same. Okay, so now that we've talked about the scientific method, let's go over to now the basic of matter. So first, let's say the definition of a compound. The compound is a pure substance of two or more elements that are chemically bonded in fixed proportion. H2O is a good example. A molecule, though, is a collection of chemically bonded atoms, two or more, and so that could be H2O or N2O2, Z3, anything you got. So this is like a square and rectangular situation. All compounds are molecules, but not all molecules are compounds, if that makes sense. A compound needs two different atoms in it, two different elements in it, whereas a molecule can have the same element. So, matter has mass and occupies space. So you can split that off into two things. You can split off into a pure substance, or you can split off into a mixture. It is important to differentiate between the two because you can separate mixtures, but pure substances you cannot. And so if you have a mixture of something, it could tamper with your experiments versus if you have a pure substance of something. So if a pure substance can be broken off, can be separated, it is a compound. So for example, water. And that can be separated chemically into a chemical separation will break out the compound. Or if it cannot, a pure substance cannot be separated, it is then an element, and a good example would be gold, and there's no separation in that instance. Same with, if you have 4 atoms of phosphorus, then it is still an element, it is not a compound. It needs to be separated, and a compound has 2 different atoms anyway. If from matter you go into a mixture, then you have a homogeneous mixture and a heterogeneous mixture. I struggle saying that. Heterogeneous mixture. I didn't write out the whole thing. I just put homo and hetero. All right, so homogeneous mixture would be vinegar, and that's just like the same substance. You could probably separate that chemically, but it's all the same thing. It's all like for vinegar, for example, it's just the acid. And heterogeneous, though, it's salad dressing, which actually probably has some vinegar in it, and it can be separated. There's 3 types of separation it talks about. It talks about distillation, which is just evaporation. like distilled water. And it has a cool example in the book about this distillation system where there's a clear dome over the sea, and even though it's salt water, you get fresh water from the dome because it's evaporated and it leaves the salt behind. There's filtration, where you filter the substance through a small opening or mesh opening, and it leaves the larger mass that you don't want behind. There's also chromatography. That's like when you get a pen and you put a pen on a piece of paper and you leave it in water for a while, and the water seeps up it and it spreads the colors of the ink apart. What it's doing is it's spreading the chemicals of the ink apart into the different pieces of parts of the pieces of paper, and so you've separated the chemicals within that heterogeneous mixture. I've got to practice saying that. Okay, so this raises the question of like, how do chemicals do that? How do I know which chemicals will do that and things? Well, first we know, so it brings us to that chemicals have property, or mass has properties. There are intensive properties, which are independent of substance. For example, gold will melt at some degree of Kelvin or Fahrenheit or Celsius or whatever. Extensive is it varies with the amount of substance. For example, this gold weighs 10 pounds, but it's because there's, this amount of gold in it, or it has this density or volume because it has this amount. Things like that, little measurements. There are also chemical properties, which are only observed when reacting with another substance. For example, when you put vinegar and baking soda together, the chemical property is that they react with each other and they'll explode or fizz up or create gas. And a physical property is that it's not, the atoms itself are not changed. It is also reversible, or in some cases it's reversible, except when you rip a piece of paper, I guess. And it's just on the outside. The atomic makeup of the compound or molecule does not change. So that brings us to what kind of physical changes are there? And there are the phases of matter. So this is like I said, physical change, and it goes from solid liquid to gas, or gas liquid to solid. Sometimes, though, a gas will skip to a solid and a solid will skip to a gas. When a solid goes to a gas, it's called sublimation. When a gas goes to solid, it's called deposition. To do this, though, to create a change in phase of matter, it requires energy. So in this class, what the professor said was that energy is going to, we're going to talk about potential energy, which is like when the book gave you an example of that there's chemicals within your muscles, and those chemicals within your muscles have potential energy, which can now then move your muscles, which are turned into kinetic energy, movement. And then there's also radiant energy, which is light. And that, for example, glow sticks, they react off of light, or glow-in-the-dark things. When you put them up to a light, they glow more because they have a certain chemical in them. Okay, so that covers our first day of class in Chem 105.